Okay, we've been looking at special triangles. We've been looking at angles in degrees and in radians. We've been looking at angles in standard position. If you deliberately take our XYR, point on the terminal side, position on the definitions of the trig functions, and you want a point to actually lie on the unit circle, what we said before in our earlier discussion, so that means the radius is 1. So that's the only difference, is you're forcing the radius to be 1. Now let's look at the angle negative 5 pi over 4 radians. I would like for you to notice, I asked you guys to certainly memorize some special angle values, and pi over 4 is actually 45 degrees. So this angle is actually literally negative 225 degrees. So it's really up to you if you want to convert from radians to degrees and then do your measurements, or if you want to count in radians. I think it's good to know how to do it each way. If we measure negative 225 degrees, that puts us bisecting the second quadrant as we are measuring in the negative direction. Now this means if you look at the proximity to either 180 degrees or measuring backwards negative 180 degrees, that our reference angle is 45 degrees, and what we form is a 45-45-90 right triangle relationship here. Now notice I've given you two triangles. Okay, and the two triangles are the one that we naturally drew as a right isosceles triangle and the one that we scaled down for the unit circle approach. Both are legitimate, both work. It's just that when you're trying to pick a point on the unit circle, you are deliberately picking a point that fits the requirement that the radius is 1. So basically what we're going to do is look at the radius here being 1, the distance between the origin and the point, and look at the values relative to that for the sides of the triangle, and notice that we're in a quadrant where the ordered pair would be left and up. So we have an ordered pair of negative 1 over root 2 comma positive 1 over root 2, and remember r equals 1. That's important. So the sine value being y over r, if that's y divided by 1, then the sine value is just the y coordinate of the point on the unit circle. Likewise, x over r, the cosine value is simply the x coordinate of the point on the unit circle. Tangent is the y value divided by the x. That would reduce to negative 1. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. And everything falls nicely into place. But again, whether we use an arbitrary value for r or whether we are forcing our r to equal 1 to be on the unit circle, the outcome is the same.